In 1929, the Soviet Union's military leadership faced an uncomfortable truth. Their armed forces still carried revolvers designed when Alexander III ruled Russia. The Nagant M1895 revolver was reliable enough, but it was slow, awkward to reload under stress, and represented thinking from another era. Meanwhile, Western armies were adopting semi-automatic pistols, weapons that could be reloaded quickly, carried more ammunition, and reflected modern engineering principles. The Red Army needed to modernize, but they needed to do it within the constraints of Soviet industrial reality. The design trials that year attracted several submissions, but the specifications were brutally practical. The winning pistol needed to be powerful enough for military use, simple enough for mass production in factories still being rebuilt, reliable enough to function in conditions ranging from Central Asian deserts to Siberian winters, and maintainable by soldiers with minimal technical training. These weren't theoretical requirements, they reflected the actual state of Soviet manufacturing and military infrastructure in the late 1920s. Fedor Tokarev, already known for his work on machine guns, submitted a design that immediately distinguished itself not through innovation, but through radical simplification. While other designers tried to impress with novel mechanisms, Tokarev essentially asked, what if we took proven Western designs and stripped away everything that wasn't absolutely necessary? His pistol borrowed the short recoil system from Browning's work, simplified the locking mechanism, eliminated decorative elements, and used manufacturing processes that didn't require precision equipment most Soviet factories didn't have. The weapon that emerged from Tokarev's workshop looked almost brutally utilitarian. Flat steel sides, simple straight lines, exposed machining marks that Western manufacturers would have polished away. The grip frame was a simple steel stamping. The barrel locking used straightforward lugs rather than complex cam systems. Even the sights were basic notches and posts, functional but nothing elaborate. To eyes trained on European craftsmanship, it might have looked crude. To Soviet production managers calculating how many units they could manufacture per month with available equipment, it looked like the answer to an urgent problem. By 1930, after refinements and testing, the design was officially adopted as the TT-30, with the improved TT-33 following 3 years later. The designation was simple. TT stood for Tula Tokarev, combining the name of the Tula arms plant, where it would be produced with its designer's name. The number indicated the adoption year. No elaborate naming ceremonies, no patriotic designations, just functional identification that told you exactly what you needed to know. If stories like this help you see how engineering quietly shaped history, tell us in the comments what surprised you so far. And stay with us for the next chapter. Fedor Vasilyevich Tokarev wasn't a young revolutionary when he approached the pistol design challenge. Born in 1871 in a Cossack village, he was already 58 years old in 1929, an age when many engineers consider retirement, not embarking on projects that would define their legacy. His career had been built on understanding one principle: military weapons succeed when they match the capabilities of the people who must build and use them, not when they showcase theoretical perfection. Tokarev's background gave him perspective other designers lacked. He'd worked at the Tula arsenal since before the revolution, witnessing firsthand how weapons performed not in ideal conditions, but in the chaos of real military logistics. He'd seen sophisticated designs fail because spare parts couldn't reach the front, because maintenance required skills most soldiers didn't have, because manufacturing tolerances couldn't be maintained in wartime conditions. He understood that a weapon's true measure wasn't how well it performed in a factory testing facility, but whether it still functioned after being carried through mud, stored in freezing temperatures, and maintained by someone whose only training was a quick demonstration by a sergeant. The pressure on Tokarev in 1929-1930 was substantial, though different from the drama often associated with weapons development. There were no enemy armies at the gates demanding immediate results. Instead, the pressure came from a more abstract but equally real source: the Soviet Union's desperate need to modernize its military while simultaneously industrializing a largely agricultural nation. Every design decision Tokarev made existed within this context. Could existing factories produce this part? Could workers with limited training assemble it correctly? Would it survive the supply chain between factory and frontline unit? This wasn't the kind of pressure that produces eureka moments and revolutionary innovations. It was the pressure that produces careful compromise, intelligent adaptation, and ruthless simplification. Tokarev spent countless hours examining the Colt M1911, the Browning high-power designs, and other Western pistols, not to copy them exactly, but to understand which elements were essential and which existed only because Western factories could afford the luxury of complexity. He borrowed the short recoil system because it worked and was relatively simple. He borrowed the locking lug concept because it was straightforward to machine, but he eliminated or simplified everything else. His team at Tula worked in facilities that, by Western standards, were modestly equipped. They didn't have the precision grinding machines common in American or German factories. They couldn't assume perfect heat treating or exact dimensional control. Every design choice had to account for these limitations while still producing a functional weapon. This wasn't design work as artistic expression. It was engineering as problem-solving under constraint, which is perhaps the truest form of the discipline. The mechanical heart of the TT-33 is deceptively simple, which was precisely Tokarev's intention. When you pull the trigger, the hammer falls forward, striking the firing pin and igniting the cartridge primer. The explosion drives the bullet forward through the barrel while simultaneously pushing the cartridge case backward with equal force. Newton's third law in action. This is where the engineering begins. The barrel and slide are locked together by two lugs, machined into the barrel that engage corresponding recesses in the slide. As the bullet travels down the barrel, both barrel and slide recoil rearward as a single unit, remaining locked together for the first few millimeters of travel. This initial locked phase is crucial. It ensures the chamber doesn't open while high-pressure gas is still pushing the bullet forward. Opening too early would be catastrophic, allowing hot gas to escape rearward and potentially rupturing the cartridge case. After traveling approximately 5 millimeters together, a simple cam mechanism causes the barrel to tilt downward, disengaging the locking lugs from their recesses in the slide. This unlocking happens at precisely the moment when chamber pressure has dropped to safe levels. The bullet has left the barrel, and residual gas pressure is low enough that separating barrel and slide won't cause problems. The timing isn't controlled by complex mechanisms, but by careful calculation of distances, masses, and spring tensions. It's mechanical mathematics expressed in steel. Once unlocked, the slide continues rearward alone, extracting the spent cartridge case from the chamber and ejecting it through a port on the right side of the weapon. The recoil spring, compressed during this rearward travel, now reverses the process, driving the slide forward. As it moves forward, the slide strips a fresh cartridge from the magazine, pushes it into the chamber, and as it reaches its forward position, the barrel cams back up into the locked position. The weapon is now ready to fire again. This entire cycle, from trigger pull to ready to fire again, takes perhaps a quarter of a second. Tokarev's simplification appears in the details. The barrel link that controls the tilting motion is a simple hinged piece, not the complex cam system used in some designs. The locking lugs are straightforward rectangles machined into the barrel, not intricate interrupted threads. The trigger mechanism uses a simple hammer and disconnector system without the refinements found in target pistols. Even the magazine is a basic stamped box, no complex followers or elaborate spring arrangements. The cartridge itself, the 7.62 25mm Tokarev round, reflects the same philosophy. It's essentially a stretched version of the Mauser 7.63 25mm, chosen because it offered high velocity and flat trajectory from a relatively simple bottlenecked case that was easy to manufacture. The round is overpowered for a pistol by most standards, but Soviet doctrine cared less about shooter comfort and more about penetration and range. Do you think this design choice was inevitable or a risky gamble at the time? Share your view in the comments and pass this story to someone who enjoys understanding how things really work. The transition from TT-30 to TT-33 illustrates how even simple designs require refinement through testing and use. The original TT-30 model, adopted in 1930, functioned adequately, but revealed issues when subjected to large-scale field testing with regular military units, the kind of testing that can't be replicated in a factory-proving ground. Soldiers discovered that the locking lugs, while mechanically sound, were positioned in a way that made field stripping slightly more complex than necessary. The hammer assembly, though reliable, required more steps to remove than ideal for field maintenance. Tokarev and his team spent 3 years analyzing field reports, examining worn components returned from units, and interviewing armorers about common maintenance issues. This wasn't dramatic failure leading to urgent redesign. It was the methodical process of identifying friction points in the user experience and addressing them systematically. The changes between TT-30 and TT-33 were subtle enough that many soldiers probably didn't notice them, but they reflected genuine engineering improvement based on empirical evidence. The TT-33 modifications included relocating the locking lugs to positions that allowed simpler barrel removal, redesigning the hammer group to reduce the number of components, and refining the tolerances to better accommodate mass production variations between different factories. Tokarev also standardized certain dimensions that had varied slightly in the TT-30 production, creating better interchangeability of parts between weapons, a crucial advantage for military logistics. Testing protocols for Soviet firearms in this era were comprehensive, though different from Western approaches. While Western testing often emphasized precision and consistency under ideal conditions, Soviet testing focused on function under degradation. What happens when parts are worn, when maintenance is delayed, when the weapon is dirty, cold, or damaged? Testers deliberately used weapons without cleaning them for extended periods. They exposed them to temperature extremes. They dropped them, immersed them in mud, and generally subjected them to conditions that approximated or exceeded field reality. The TT-33 performed adequately in these tests, not because it was precision-engineered to tight tolerances, but because it was designed with generous tolerances that allowed it to function even when conditions degraded. Parts that were slightly out of specification still worked. Dirt that would jam a tighter tolerance weapon was simply forced out by the relatively crude tolerances. This was intentional design, not manufacturing sloppiness. Tokarev understood that weapons must function in the world as it is, not as we wish it would be. Factory production ramped up through the 1930s, with multiple Soviet arsenals producing TT-33 pistols, according to standardized specifications. The simplicity of manufacture meant that factories with relatively unsophisticated equipment could produce acceptable weapons. This wasn't ideal. Variation existed between different production facilities, but it was achievable, which in Soviet context was often more important than perfection. The most distinctive feature of the TT-33 is what it doesn't have: a manual safety mechanism. For anyone familiar with Western firearms tradition, this omission seems shocking, perhaps even irresponsible. Virtually every Western military and civilian pistol of the era incorporated some form of safety lever or button, a mechanical interlock that prevented the weapon from firing even if the trigger was pulled. The TT-33 has none of this. Pull the trigger with a round chambered and the hammer cocked, and the weapon will fire. There is no external control to prevent this beyond keeping your finger off the trigger and possibly using the half-cock notch on the hammer. This wasn't an oversight or cost-cutting measure, though those explanations are sometimes offered. The absence of a safety mechanism was a deliberate engineering and doctrinal decision that reveals how Tokarev thought about reliability, training, and military reality. A safety mechanism adds multiple components: levers, springs, sears, and interlocks. Each additional component is another potential failure point, another piece that can break, freeze, or malfunction. In harsh conditions, a safety mechanism might fail to disengage when needed, or worse, might fail in a way that allows discharge when it shouldn't. Mechanical complexity always carries this double-edged risk. Tokarev's solution was to eliminate the mechanism entirely and compensate through training and handling discipline. Soviet military doctrine emphasized collective training and standardized procedures. Soldiers were taught to carry the weapon with the chamber empty until immediate action was expected, then to chamber a round when necessary. They were taught trigger discipline. Keep your finger outside the trigger guard until ready to fire. They were taught to use the half-cock notch as a carrying condition when a chambered round was necessary. These weren't novel ideas, but implementing them as doctrine rather than relying on mechanical safeties was a different philosophical approach. The decision also reflected Soviet views on combat psychology. A safety mechanism requires a conscious action under stress. Remember the safety, locate it with your thumb, disengage it, all while managing the immediate threat that prompted you to draw the weapon. Soviet doctrine preferred to eliminate this step entirely. If you're drawing the weapon, you're prepared to use it, and you should be able to do so immediately without fumbling for safety controls. This philosophy prioritized speed of engagement over mechanical safeguards, placing responsibility on training rather than mechanisms. From an engineering perspective, eliminating the safety simplified manufacturing significantly. Fewer parts meant fewer machining operations, fewer components to inspect, fewer assemblies to coordinate. It meant the trigger mechanism could be more robust because it didn't need to integrate with safety interlocks. It meant field maintenance was simpler because there was one less system to diagnose if something went wrong. In a military force that would eventually number millions, where weapons might be issued to soldiers with minimal training time, this simplification had practical value beyond just manufacturing efficiency. The legacy of the TT-33 extends far beyond its original Soviet military service, though that alone would justify its historical significance. The weapon remained in Soviet production until 1952, with millions manufactured across multiple arsenals. But its influence spread through a network of licensed and unlicensed production that made it genuinely global. China produced its Type 54 variant in massive numbers, eventually becoming one of the most widespread handguns in Asia. Poland, Yugoslavia, North Korea, Egypt, and other nations either licensed the design or simply copied it, recognizing that Tokarev had created something valuable, a working pistol that didn't require sophisticated manufacturing infrastructure. This proliferation wasn't primarily about the weapon's performance characteristics, though it performed adequately. The TT-33 wasn't more accurate than Western competitors, wasn't more comfortable to shoot, wasn't more elegant or refined. Its advantage was manufacturability, combined with acceptable function, a combination that proved more valuable than excellence in any single dimension. Nations building their defense industries from limited foundations could actually produce the TT-33 with equipment and expertise they possessed, rather than aspirational equipment they hoped to acquire someday. The design's influence appears in unexpected places. The Chinese Type 54, while visually similar, incorporated subtle improvements based on decades of production experience. The Yugoslav M57 added a safety mechanism, ironic given Tokarev's deliberate omission, reflecting different doctrinal preferences. The Egyptian Tokarev used 9mm parabellum ammunition, adapting Tokarev's design to different cartridge logistics. These variations demonstrate how a well-conceived basic design can be adapted to different needs while retaining its fundamental character. From an engineering perspective, the TT-33 validates a particular philosophy. Appropriate technology trumps optimal technology when manufacturing and maintenance constraints are real. Tokarev could have created a more sophisticated pistol. He understood the mechanisms involved, had access to Western examples, and possessed the technical knowledge. Instead, he created what Soviet industry could build and Soviet logistics could sustain. This required understanding not just mechanical engineering, but the broader system within which the weapon would exist. The weapon's longevity tells its own story. TT-33 pistols remained in service in various nations into the 21st century, 70 years after their design, not because they were exceptional, but because they were sufficient, and because their simplicity made them practically immortal. They could be rebuilt with basic tools, maintained by soldiers with minimal training, and kept functioning through neglect that would render more sophisticated weapons inoperable. This robustness, born from simplification rather than refinement, proved more valuable across decades than the precision engineering of more celebrated designs. Perhaps the ultimate tribute to Tokarev's pragmatism is that his pistol succeeded by being forgettable. It never achieved the iconic status of the Colt M1911, never inspired the collector devotion of German Lugers, never appeared in films as a symbol of sophistication or power. It was simply there, working in the hands of millions of soldiers and security forces across continents and decades. For an engineer who prioritized function over form, who trusted simplicity over sophistication, this quiet ubiquity might be the highest achievement, proof that understanding constraints and designing accordingly creates value that endures long after more glamorous alternatives have failed. If you enjoy calm, true stories about how engineering shaped the world, subscribe to the channel, leave a like, and tell us from which country you're watching.